I'd like to take a minute and show you how to solve a chi-square test of independence using Rguroo. Consider a particular question from the Quinnipiac University poll. The Quinnipiac University poll is often used as a barometer for public opinion regarding matters of public concern. The question we're going to look at today that was asked of the respondents was, would you support or oppose raising the national minimum wage? So we can see the results here in the contingency table. I'm going to assume support is yes and oppose is no. I can also see that they gave us, in addition to their response, their political affiliation as either Republican, Democrat, or Independent. The next question we're going to look at is, based on the data, can we conclude that the support for raising the national minimum wage is dependent on political affiliation? This question of dependency makes me think, hey, we probably have a chi-square test of independence here. Also, if we look at the data, we can see that we have two qualitative variables that are summarized in our contingency table. So this is the perfect situation to use a chi-square test of independence. So our null hypothesis will say support for raising the national minimum wage and political affiliation are independent, that meaning they're not related, and support for raising the national minimum wage and political affiliation are dependent, meaning that they are related. So our hypothesis statements in these situations are not symbols or numbers. They are sentences that declare independent in the null and the two variables being dependent in the alternative. So let's take a moment and let's open up Rguroo to see if we can get it to solve this for us. So we get into Rguroo. We're going to want to communicate the contingency table, which is our evidence for this hypothesis test. We'll click on the data panel on the left. On the drop-down menu, we're going to choose Create New Data Table or Create New Table. This is not raw data. This is data that's already summarized, so we're going to have to enter it as a table. Once we get in there, we can start typing our data, our contingency table in. Now, we're not going to type in the red box. They want you to stay out of that one, so they made it red. And so in that first gray column, we're going to type the political affiliations of Republican, and I'm just putting abbreviations, Democrat, and Independent. In our columns, we're going to put yes and no. So that's the basic framework of our 6 cells we had there. And I'm going to start to type those numbers in from our first slide there. And for Democrats, we had 387 yeses and 30 nos. And for our independents, we had 476 yeses and 193 nos. Now, I want you to notice that I did not put the column totals or the row totals in this table. They are not needed. We only put the 6 major cells here that were communicated that classify people by their political affiliation and their opinion. Before we try to save this, we need to do some labeling. Our row variable was political. You could put more than that. I'm putting political short for political affiliation. Our column variable describes their opinion. And here for frequency, I'm just going to put number. In other words, each of the cells represent the number of individuals who fell into these classifications. For example, here 30 is there are 30 Democrats that said no to the survey question, or that they oppose raising the minimum wage. Let's save this. Let's save it as Quinnipiac. Probably spelt that wrong, but Quinnipiac, or you can save it whatever you want to save it as. We'll save that. Now that the data table is saved, we're going to minimize the data panel on the left. I'm going to go down to Analytics, open up that panel, choose the drop-down box, and about halfway down we can see there's a contingency table option. We're going to select that one. The thing I need to communicate to our guru here is our information. So we're not going to select a data set. We're going to select a data table. They're all in the same place. I'm going to click on the drop down here. And because of a lot of data sets I have for teaching and work, I'm going to go down and I'm going to choose Quinnipiac. That's what I named my data table. I also want you to notice that it has kind of a different icon there to the left than data sets do. The data sets are kind of, it looks like a little table that's purple, whereas you can see here next to Quinnipiac, there's just a different kind of icon that looks more like a contingency table. Our factor 1 is our row variable, which is political. Factor 2 is our column variable, which we called opinion. And then frequency, remember I called that number. So you can see those are repeated over here, the factors to the right in those boxes. And the last thing we have to do is choose the chi-square test. Now, I realize as I look down here, there's one other option, which is significance level, and our problem wasn't given one. So I'm going to just leave it as the 0.05 that's there. It's kind of a middle of the road significance level, since one wasn't given. We'll just leave it there. And we click the preview button. So what you can see here is that we have the table that we gave it. It's in alphabetical order, so no is first, then yes. And of course, it alphabetized the political affiliations. But you can double check, spot check the numbers. The total column and the total row are back, so they will be back after you give them. It knows how to figure those out, so they were not needed in the data entry. Let's go down and see the chi-square test. We see that we have a test statistic. This is our chi-square test statistic of 170. It's really, really large. And if we go to the right of this table, we have the probability value, which is 0.50. So it's essentially really small. It's smaller than the number of decimals that our guru bothers to display. So it's smaller than 0 followed decimal followed by 5 zeros. So it's really, really tiny. If we're curious exactly how tiny it is, you can see here they gave it in scientific notation, which is 9.6 times 10 to the negative 38. So super small. And then there's the chi-square value again in the graph. If we scroll down some more, we will see the expected counts. If you're ever needing those for any reason in a question, they are there at the bottom of the output page. So let's kind of catalog what we know. Our chi-square was 170. Our probability value was 0. I'm just putting all those zeros in. Our significance level, we just chose the 0.05 since one was not given. And when we do this comparison of our probability value, is certainly less than alpha, so smaller than our significance level. So we will reject our null hypothesis. And that's our decision based on the evidence. So I like to repeat these. We were told to reject the null, so I'm going to come in here and a little dramatic flare and literally cross it out. We've rejected it, which means that all we have left is our alternative, and that's what our data is in support of, is our alternative hypothesis. And if we read it back to ourselves, we can see that it says that the two variables are in fact dependent. So our summary statement's even easier to write in most circumstances because our hypotheses are already sentences. And your summary statement could sound something like, there is sufficient evidence to conclude that support for raising the national minimum wage and political affiliation are dependent, or they are related to one another. Hope this was helpful. Reach out if you have any questions about Rguroo.